Section 10.1 is the Pythagorean Theorem. I can solve problems using the Pythagorean Theorem, and I can identify right triangles. Big ideas here. The lengths of the sides of a right triangle have a special relationship. If the lengths of any two sides of a right triangle are known, the length of the third side can be found. If the length of each side of a triangle is known, then whether the triangle is a right triangle can be determined. There are special names for the sides of right triangles. The side opposite the right angle is called the hypotenuse, and that's always our longest side. The sides that form the right angle are called the legs, and those are our two shorter sides. So the take note on page 614 talks about the Pythagorean theorem. In any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. A lot of words to tell us that a squared plus b squared, these are our legs, equals c squared, our hypotenuse. We can use the Pythagorean theorem to find the length of a side of a right triangle if we know two of the other sides. The tiles on page 615 are squares with 6-inch sides. What is the length of the hypotenuse of the right triangle shown? So here, in the picture, obviously a better picture and more in depth, it shows us that this is a right angle, and we're looking for the length of the hypotenuse. Pretend this is a straight line all the way across. And we're looking for this length. Okay, the length across diagonally. So in order to find that, we're going to use Pythagorean theorem because we know two sides of our triangle, 6 and 6, and we're looking for the third. So my legs are my A and my B. 6 squared is 36. 6 squared is 36. Add them together, we get 72 equals c squared. Now, in order to get rid of a squared, okay, and we've talked about this before, to get rid of something square, we take the square root of both sides. And when I take the square root of 72, it's approximately 8.49 inches, so about 8.5 inches here. So usually our answer would be the square root of 72, but here because we're trying to talk this actual measurement, I went ahead and took that to our decimal. Now we want the length of the hypotenuse of a right triangle if our legs are 9 and 12. So the legs are our A and our B. Hypotenuse is always C. And we're looking for the length of the hypotenuse, and we have our legs. So a squared plus b squared equals c squared. 9 squared plus 12 squared equals c squared. 9 squared is 81. 12 squared, 144. When we add those together, I get 225. And when I take the square root to get rid of my square and get my c completely by itself, I get 15 equals c. And usually when we take the square root, we do plus or minus, but here we're talking about a distance. So 15 centimeters is my answer, not plus or minus 15. Same idea here. I have a right triangle, and I know two of my sides, and I'm trying to find the third. So here, again, Pythagorean theorem, a squared plus b squared equals c squared. I take my legs, 5, and I'm looking for b, so I keep b just b, but I know my hypotenuse or my c value is 13. So here I'm going to simplify both sides before I can solve. 5 squared is 25, and 13 squared is 169. Now, to get my b value by itself, I first need to get my b term by itself. So I subtract the 25 to move it to the other side and get my 0 that I need with my b squared. Now I take the square root to get rid of my square, and b equals 12 centimeters. Now what's the side length, A, in a triangle at the bottom of page 615, which I have here as well? Again, we're looking for one of our sides. So a squared plus b squared equals c squared, and this works because we know two side lengths of a right triangle. So a squared plus my other leg is 12 squared equals my longest side or opposite of my right angle, 15 for my hypotenuse. I'm going to go ahead and get rid of my exponents first. Now that both sides are as simple as I can get them, I'm going to solve and get my a by itself by first subtracting. And then taking the square root. And here I get 9. An if-then statement such as, if an animal is a horse, then it has 4 legs, is called a conditional. Conditionals have 2 parts. The part following the if is the hypothesis. The part following then is the conclusion. The converse of a conditional switches those 2 parts. Sometimes these converse statements are not true. So for example, if I said, if an animal is a horse, then it has 4 legs. Okay, that's true. I mean, almost always. Sometimes things happen, but horses have 4 legs. If I were to say that backwards, if I were to say the converse of that, I would say, if an animal has 4 legs, then it is a horse. And there's no guarantee on that. That's not always true. Sometimes it's true, but not always. Maybe it's a cat. It's probably an elephant. Could be a turtle. We don't know. So, not necessarily a guarantee if we have the converse. So we have to be careful there. When we use this idea with the Pythagorean theorem, we can help determine if a triangle is a right triangle. So if a triangle is a right triangle with legs a, b, and hypotenuse c, then a squared plus b squared equals c squared. And our converse is always true. So if a squared plus b squared equals c squared, then we have a right triangle with legs a, b, and hypotenuse c. So here we're going to figure out if any of these sets of side lengths can be right triangles. So in order to know that, guys, we can use the Pythagorean theorem. So if a squared plus b squared equals c squared, then yes, it's a right triangle. So when we do this, guys, we can pick any 3 sides. The only thing that matters is that our biggest number goes in for c, our hypotenuse. So 6 squared plus 24 squared equals 25 squared. Let's check this. 36 is what we get when we take 6 squared, 24 squared is 576, 25 squared, 625. When we add these up, 576 plus 36 is going to give me 612, which does not equal 625. So since a squared plus b squared is equals c squared is not true, this is not a right triangle. Let's try it again here. A squared plus b squared equals c squared. Again, we pick out our biggest side. That has to be our c value. Now, 4 squared plus 8 squared equals 10 squared. Let's check it. 16 plus 64 equals 100. When we add them up, we get 80 equals 100, which again is not true. So since a squared plus b squared does not equal c squared, this is not a right triangle. Let's try it for c here. Again, we pick out our biggest side as c. 10 squared plus 24 squared equals 26 squared. 100 plus 576 equals 676. 676 equals 676. This one checks. So since this is true and our Pythagorean theorem is true, then yes, we have a right triangle. And on D here, a squared plus b squared equals c squared. Again, we pick out our longest side length. That has to be c. So it's not necessarily because it's the third one listed. It's because it's our longest side length. And I plug in my 2 legs for a and b, my 2 shorter sides. I get 64 plus 225 equals 256. Here I get 289, and 256, and those are not equal. So no, this is not a right triangle. Now, could the lengths 20 millimeters, 47 millimeters, and 52 millimeters be the side lengths of a right triangle? Explain. A squared plus b squared equals c squared. We pick out our longest side, and that has got to be our c value. The other two are our legs, and they can go in for either a or b. So 20 squared plus 47 squared equals 52 squared. 20 squared is 400. 47 squared is 2209, and 52 squared is 2704. And we're checking, are these equal? Here I get 2609, which is not the same as 2704. So since those are equal, these could not be not a right triangle, because a squared plus b squared does not equal c squared. Quick recap here for section 10.1. The lengths of the sides of a right triangle have a special relationship. If the lengths of any two sides of a right triangle are known, the length of the third side can be found. And if the length of each side of a triangle is known, then whether the triangle is a right triangle can be determined. And that's all I have for section 10.1.